Hello, my friends. Welcome to my channel. This is your coach, Mr. Magno. Today we're looking at Module 5, Lesson 17, and we're going to answer this question. What is a parallelogram? And to answer this question, we're going to look at the attributes. The attributes is a fancy word in mathematics that says, what are the characteristics of a parallelogram? All right, let us begin. So a parallelogram, let me give you the first attribute. So this is going to be the attributes. A parallelogram is it's a quadrilateral because it has four sides. So we're going to draw one right here. But here's what happens. This is segment A, B, and we're going to draw segment. We usually go like this. Watch this. A, B, C, D. Okay, so this is C, D. So if you see segments AB and DC are parallel to each other. So this is a symbol that shows that they are parallel. And in segment BC and segment AD, they are parallel. So we are going to show these parallelograms. So that is the second attribute of a parallelogram. It has two sets of parallel lines. Two sets of parallel lines. So that's the next attribute. Now let's look at one more attribute about this is a 90-degree angle, and all of them are 90-degree angles. So when you total the 90-degree, all angles, this is a symbol for angles, equals 360 degrees. Now, do they all necessarily be right angles? I don't think so. Let's do one more. In this time, we're going to do a rhombus. I made a mistake a little while ago. A rhombus is a shape. Okay, these are segments. Let's see, segments A, B, and this is segment D, C. And let's pretend they're all the same, but these two are parallel from each other. Okay? Now, what makes a rhombus is that the sides, all the sides are the same. It's like a square, like a tilted square. So now we know that segment AD is parallel to segment BC, and that will be a rhombus. So now we have a rectangle and a rhombus, and they both are parallelograms, and they are also both quadrilaterals. However, they're parallelograms because they have four sides, they have two sets of parallel lines each, and all the angles equals 360 degrees. Now, here the angles we have obtuse. These opposite angles have the same value. And this D angle and the B angle have the same value. I think I said that incorrectly. A and C have similar angles, and B and D have similar angles. So let's say, for example, that this is, if you can imagine, if you had this line right here, that was 90 degrees, right? So that's less than 90. So let's call it 65. No, let's call it 65. And because the opposite angle is the same, so B, the angle B is 65 degrees. Now, what are the degrees for C and A, which they both similar? If you remember that the whole thing has to equal 360, so this half has to equal 180. So this is the math what you need to do. 180 minus 65 equals 115. Okay, let me see, that's 10, that's yes. So this angle C will equal 115, and this angle A will equal 115 degrees. When you add all of the angles, when you total their value, it should equal 360 degrees. Again, we always go back to the attributes. Remember, the attributes of a parallelogram have to be it has to be a quadrilateral. It has to have two sets of parallel lines, and all the angles must equal 360 degrees. Okay. Okay, let's see. So can we make now, can a trapezoid be a parallelogram? Well, I don't know. Let's see a trapezoid. Let's look. So a trapezoid starts like that. Is this line parallel to the bottom line? Let's call this again A, B, D, C. Is segment AB the same as parallel to DC? And the answer is, of course. Okay, now let's look at the segments AD and the segment BC. So is this are these two parallel? Well, I don't think so. Here's the reason why. If you continue these lines, they're going to meet, eventually they're gonna connect. So that means these two are not parallel. Now here is the symbol when something is not parallel. This is not parallel to this. So is a trapezoid a parallelogram? I don't think so. Okay,